In this video, we're going to talk about a Python framework for doing time series machine learning, which is called DARTS, D-A-R-T-S. The TS is stand for time series. Okay, so let's go to the website. Also, the title of this framework says time series made easy in Python. So it is a Python library that is user-friendly for forecasting and annotation and other things for time series. So it is not strictly restricted to doing autoregressive generating things. It can do a lot of different things. So, but it contains a lot of different algorithms. Start from something like the very easy one or baseline one or like a statistic one like ARIMA that we have already introduced before, and neural network one. So it is very convenient for you to train and test for a lot of different framework. I mean different model architectures or algorithms. Especially if your problem is a typical time series problem, it will be very easy for you to do so. And it has a scikit-learn-like interface, so you have a fit and predict as well. It also contains some data type that is called the time series. So it makes a lot of sense because this is a library dealing with time series data and machine learning algorithm. So it actually accept the main data pipeline is using a data structure called the time series. So that's why I say that if your problem is some typical time series problems, then it would be very suitable for using an very convenient to using this framework, this library. However, if you are trying to do some not so typical problem, so for some situation, you might want to transform some problem into a time series problem. However, there are some differences. They are essentially the same, but there are some differences in data handling. Then there might be some issues. You might not need to hack into the data pipeline to use this framework. So that might be a little bit of a challenge. It is doable because I have done this before. But I can imagine that if you are not that familiar with the PyTorch pipeline, then it might be somewhat difficult. However, I can safe to say that if your problem is some standard, typical time series problem, then you can use this DARTS to test various algorithms really quick and conveniently. So what kind of algorithm does it contain? It has packed in this library. It actually has a table to show what kind of algorithm, what kind of models it has. It starts from very naive ones, like naive mean. Pretty much just choose the the average of the history and as a prediction. From some statistical one, classic models like ARIMA and the phi ARIMA. It actually means vector ARIMA. And to the deep learning one, and the scikit and actually tree-based models like LightGBM, XGBoost, KBoost, that were very powerful models, and also some deep learning models like the deep learning models are based on Lightning, which like I mentioned, maybe mentioned last week, that is one of my favorite framework to use. And so it has a basic something like RNN, like LSTM, GRU, or more sophisticated models like NBIT, TCNM. It might stand for temporal convolution neural models, and transformers models, and TFT. Those are all very kind of famous and popular models. I would say popular models. Um, Another reason I like to introduce this model is, I mean this framework, is because it has a very good table of showing the capability of these models, which kind of emphasis on the different aspect or the features that people wish that a model have, and certain limitations that often occurs in certain models. For example, the first one says of course, this green one means it has the capability, and the red one it says otherwise. For example, this is one of the characteristics of the model, like the target series support univariate or multivariate. So this might make less sense in the world of deep learning, because we always have a factor output. But for example, for ARIMA model, ARIMA model, it is originally only designed for a univariate target. So there's specifically a factor version of ARIMA model that deal with the multivariate things. So sometimes when people say something about the time series, maybe they in their mind they are thinking about the univariate time series. And the other thing is about the covariance. This is more about the accessory or supplement input for the model. Target is something that we are going to predict. So of course, because this is an autoregressive model, so or time series model, usually we are considering the past history of the target as input, and the future entries, future centers are the target, okay, as what we are going to predict. However, sometimes we need more information. We can have more information that we don't have to predict them, but it is good or maybe necessary to have the information so that we can use it for our prediction. These are called covariates. Covariates has different types. One is past observed, which means the time series that can be observed up to the current time. So that is kind of like a target, except that you don't have to predict the outcome. There are also future non-covariates. That may sound kind of weird if you are thinking about, so why can we have something that is happen in the future? So the future non-covariates are usually, this is a future non-covariates, are usually happens in two situations. One situation is some factors that we can control. Maybe we can, like if you are driving a car, we can ask a question that, okay, what would happen if we accelerate, or what would happen if we hit the brake? So that is not something we can control. Or what happened if we turn on the light or do something? So future covariate. So in that case, we know what we are going to do. So if something is that we can control, then maybe we can put it into the visual covariate, so we can do some simulation to see what would happen if we change something that we can already control. Even if something that we cannot control, we can still do the simulation. Like if we wish to design a very robust building that is able to against like very huge tornadoes or earthquake, then the earthquake or the tornado can be put into the future non-covariate. We can ask that, okay, what would happen to this building if there will be like 3 huge tornadoes in the next 3 months, or what will happen if there will be a very intensive earthquake in the following weeks. So we can give some input that we imagine that would happen. Or if you wish to predict the stock market, and you already know some features that will affect the outcome, you may wish to ask, what if this thing happens? Will the price of this stock going to be going up or going down? Okay, so that is the purpose of the future non-covariate. So you might have something that you wish to simulate or ask, what if this kind of things happen? And there also comes with some static covariate. These are things that doesn't depend on the time. So we have some parameters, some parameters that maybe is related to the situation, but it is a constant over time. So we call that kind of covariate static. So you may see that a lot of models, like naive models, this covariate doesn't make much sense. So for example, if you are considering the means, using the means of the history as a prediction, then neither of this past observed covariate or future non-covariate or even static covariate make much sense, because you simply compute the mean of the history. And some covariates are very more difficult to incorporate into your model than the others. So you can see these considerations. All of these differences indicate some limitations or something you choose to have or choose to sacrifice in your assumptions or in your consideration for when you design the algorithm. And also there is whether the output is probabilistic. Also, like what we have introduced in the basic implementations, that in some case, if you can choose to sacrifice the probability model just by simply using mean square error as your loss function, which will make the prediction deterministic, but it will make the model more simple, easier. Although it loses the capability to kind of estimate the risk or the variance of the robust or the confidence of the prediction, but in exchange, your model is easier and the loss is much simpler and stable. It's just a simple mean square error. So maybe by exchange, the benefit of reliability of risk estimations, you make these models easier to converge. Okay, so there are models with probabilistic forecasting or without. There are also two kind of different major differences between this kind of prediction. So one way to do that is like how do we do that? We actually output a distribution. So you actually output a distribution parameters. So you can actually directly access to the like so for the normal for normal distribution, you can actually has the mean and the standard deviation. So you can actually just of everything easily. And another kind of thing is you don't directly or explicitly has this information. However, it's like a generative model by changing the by changing the by sampling the model, because it is a non-deterministic, it's a probabilistic model. So you can run the models several times and get different output and use this output to estimate the output distribution, like running it like 1,000 and 10,000 times, and you can find the mean or standard deviation, or you can even find out the percentile, like 90 percentile or 25 percentile, 10 percentile. So for language model, it actually has a temperature. So you can make the models like a sampled one, because you can run the language model to generate text multiple times, and it works like a sample one. However, in most language model like ChatGPT, GPT, it because you can change the temperature, it actually has a logic of something. You can actually get some kind of probability in there. Okay, so let's just give you some example of the real world usage of a difference of this kind of things. And also there is also a concern of training or forecasting on multiple different series. So sometimes a model is not easy to do for multiple series. You can only do one series. So this is also an important concern. Okay, so in summary, Darts is a very convenient framework, and it contains a lot of ready-to-use algorithm that you can already use. So I actually recommend this framework because it helped me to do certain jobs and do it pretty well. So you can use it too. Another thing is that it is an example, especially the reason that makes me want to introduce this is not how easy or how convenient it is. It is because of this table. It actually shows a lot of different consideration of a problem, although it may appears to be pretty similar or pretty limited, but people are considering a little a lot of differences between these similar or simple model. There are a lot of different detailed considerations. So sometimes if you understand or realize there are some subtle differences, like whether there are covariates and whether the covariate is a past one or a future one. This may help you to communicate with your colleagues or other customers or other clients or other parties easily, because you can smell there might be some difference or uncertainty in certain words or situation. Because if you don't know these kind of things, all you know is input and output, and maybe if you in your mind the only time series you can imagine is the unifier time series. And when people talk about these kind of things, you have no idea what they are talking about. So I think this one is served as a really good example about some possibility of the considerations. So if you read or understand or learn these things a lot, in some case, in the future, you might be able to sense something that you haven't ever learned before, because there are some possibilities of differences in certain like certain things like the input and the output, or the mostly they are just like this one, the probabilistic or univariate or multivariate, or something like whether you are talking about something is probabilistic or deterministic, or you are talking about a single value or a vector value. Mostly, if they are not talking that specifically, one possibility is they don't understand. The other possibility is they are already talking about a more general form, but you misunderstood it. So I hope this example gives you some ideas of what you can consider. So that's all about this Darts framework.